Introduction to System Development Lifecycle. In this video, we are going to see about Introduction to System Development Lifecycle. The System Development Lifecycle, that is SDLC, is a structured sequence of phases for implementing an information system. The System Development Lifecycle is also known as Application Development Lifecycle. It is a term used in system engineering and software engineering to describe a process for planning, creating, testing, and deploying an information system. The System Development Lifecycle concept applies to a range of hardware and software configurations. An organization may feel the need for a system due to a variety of reasons. Problem faced by a person performing a function. There may be a need to improve operations. Customers may demand a better level of service organization, a different type of service which requires a system. The corporate image may need to be enhanced by using systems. It may be felt that they are necessary to enable to cope up with increased volumes and organized expansions of operations. The illustration of System Development Lifecycle. Various phases of System Development Lifecycle. In this video, we are going to see about the various phases of System Development Lifecycle. The System Development Lifecycle framework provides a sequence of activities for system designers and developers to follow. It consists of a set of steps or phases in which each phase of the SDLC uses the results of the previous one. The SDLC adheres to important phases that are essential for developers such as planning, analysis, design, and implementation. System Study, Feasibility Study, System Analysis, System Design, Coding, Testing, Implementation, Maintenance. The illustration of various phases of System Development Lifecycle. System Study. In this video, we are going to see about System Study. Preliminary System Study is the first stage of System Development Lifecycle. A system is made to solve a problem. The process therefore starts with recognition of the need. This is called as problem definition. In this phase, the key question to be answered is, what is the problem that the system has to solve? System study involves brief investigation of the system under consideration and gives a clear picture of what actually the physical system is. System study involves initial investigation and survey and should result in a clear statement of the scope and objectives of the system. System study should give a clear idea of what is expected from the system in terms of performance criteria. The initial system study involves the preparation of a system proposal which lists the problem definition, objectives of study, terms and reference for study, expected benefits of the new system, etc. in the light of the user requirements. The system proposal is prepared by the system analyst and places it before the user management. The management may accept the proposal and the cycle proceed to the next stage. The management may also reject the proposal or request some modifications in the proposal. System study phase passes through the following steps: problem identification and project initiation, background analysis, inference of findings, problem identification. The crucial phase for the success of the project is a problem identification, which is nothing but the needs of the project. Problem identification leads to an initial investigation that if the problem is solved by enhancing the existing system, or the organization will have to replace it. Problem identification is further divided into two phases. The first phase investigates, identifies, and prioritizes and arranges the problem domain. The second phase initiates the project for problem domain and a detailed work plan is made. Organizations usually maintain a proper documentation of their operation and norms. Background analysis provides the analyst with an insight into current organizational norms. Many manuals include the system requirements that help to determine how well various objectives are met. Printed forms are used extensively for soliciting and providing information. Inference of findings. Finding is a process that is done to determine whether the user requirements are met. The illustration of system study. Feasibility study. In this video, we are going to see about feasibility study. A feasibility study is conducted to see whether the required system is workable. It is concerned with questions like the requirements from the proposed system, the resources that the proposed system will require, whether the proposed system can meet the requirements, whether the proposed system will be implementable, whether the cost of creating and operating the proposed system is justified by the benefits. The feasibility study is basically the test of the proposed system in the light of its workability, meeting users' requirements, effective use of resources, and the cost effectiveness. The illustration of feasibility study. Feasibility study is categorized as technical, operational, economic, schedule, and social feasibility. The main goal of feasibility study is not to solve the problem, but to achieve the scope. In the process of feasibility study, the cost and benefits are estimated with greater accuracy to find the return on investment, that is ROI. Feasibility study defines the resources needed to complete the detailed investigation. Final feasibility report is submitted to the management. This may be accepted or accepted with modifications or rejected. Following decisions are taken in different feasibility study. Economic feasibility. The likely benefits outweigh the cost of solving the problem, which is generally demonstrated by a cost or benefit analysis. Operational feasibility. Whether the problem can be solved in the user's environment with existing and proposed system workings. Organizational feasibility. whether the proposed system is consistent with the organization's strategic objectives. Technical feasibility, whether the problem is solved using existing technology and resources available. Social feasibility, whether the problem be solved without causing any social issues, whether the system will be acceptable to the society. Detailed system study. The detailed investigation of the system is carried out in accordance with the objectives of the proposed system. This involves the detailed study of various operations performed by a system and their relationships within and outside the system. During this process, data are collected on the available files, decision points and transactions handled by the present system. Interviews, on-site observation, and questionnaire are the tools used for detailed system study. Using the following steps, it becomes easy to draw the exact boundary of the new system under consideration, keeping in view the problems and new requirements. Work out the pros and cons, including new areas of the system. All the data and the findings must be documented in the form of detailed data flow diagrams, that is DFDs, data dictionary, logical data structures, and miniature specifications. Detailed system study includes planning for the new system, analysis of requirement, system constraints, functions, and proposed system architecture, prototype of the proposed system, and its analysis. System analysis. In this video, we are going to see about system analysis. System analysis is a process of collecting factual data, understand the processes involved, identifying the problems, and recommending feasible suggestions for improving the system functioning. The analysis phase is a detailed study of the existing system, its features, and problems. The relationships of the various system components between themselves and with the environment are studied and understood. Analysis requires data collection from a variety of sources. Various tools like questionnaires, forms, interviews, study of existing documents, records, and brochures are used for this purpose. System analysis involves studying the business processes, gathering operational data, understand the information flow, finding out bottlenecks, and evolving solutions for overcoming the weaknesses of the system so as to achieve the organizational goals. In analysis phase, the system boundaries are clearly determined as it interfaces with other systems. System analysis also includes subdividing of complex processes involving the entire system, identification of data store, and manual processes. The major objectives of system analysis are to find answers for each business process. What is being done? How is it being done? Who is doing it? When is he doing it? Why is it being done? How can it be improved? System analysis is more of a thinking process and involves the creative skills of the system analyst. The focus in this phase is to understand all the relevant facts and deriving what needs to be done to solve the problem at hand. System analysis attempts to give birth to a new efficient system that satisfies the current needs of the user and has scope for future growth within the organizational constraints. The result of this process is a detailed logical model of the system along with pertinent data. The focus of this resulting document is on what the system is to do, how it is to be done is the thrust of the next phase. System analysis is an iterative process that continues until a preferred and acceptable solution emerges. System design. In this video, we are going to see about system design. System design is a phase when the what the system is to do is converted into how the system shall do it. System design is composed of the following: high-level design, detailed low-level design, inputs, outputs, files or databases, procedures, user requirements. Based on the user requirements and the detailed analysis of a new system, the new system must be designed. Design. Design starts with identification of alternate technical solutions, selecting the most suitable solution and detailing it out. This is a phase of system designing. It is the most crucial phase in the development of a system. Logical design. The logical design produced during the analysis is turned into a physical design, a detailed description of what is needed to solve original problem. In the design stage, the programming language and the hardware and software platform in which the new system will run are also decided. A cost-benefit analysis is also performed at this stage. Output of the detailed design. The output of the detailed design is used to program the system and test it out. Output design. Data structure, control process, equipment source, workload and limitation of the system, interface, documentation, training, procedures of using the system, taking backups and staffing requirement are decided at this stage. The illustration of system design. Development. In this video, we are going to see about development. Development is a phase where the detailed design is used to actually construct the system. This phase is also called as construction phase. In the development phase, the system is actually programmed. Development phase is composed of programming of the system, testing at various levels, programming of the system. The system design needs to be implemented to make it a workable system. It is an important stage where the defined procedures are transformed into control specifications by the help of a computer language. The programs coordinate the data movements and controls the entire process in a system. A well-written code reduces the testing and maintenance effort. It is generally felt that the programs must be modular in nature. Programming tools like computers, interpreters, and languages like C, C++, and Java, etc. are used for coding with respect to the type of application. Testing. Before actually implementing the new system into operations, a test run of the system is done, removing all the bugs, if any. Testing is an important phase of a successful system. After codifying the whole programs of the system, a test plan should be developed and run on a given set of test data. The output of the test run should match the expected results. The various levels of testing are as follows: unit level testing, subsystem and system testing, user acceptance testing. Unit level testing. A module is any collection of executable program statements that can be called from any other module in the program and has the potential of being independently compiled. Module testing or unit testing is therefore a process of testing the individual subprograms, subroutines, or procedures in a program. Module testing makes the debugging task much easier because it only involves a single module, and when an error is found, the error should be located within that particular module. Integration testing. Integration testing is a process of merging and testing program modules to see if they can work correctly as a whole without contradicting the system's internal and external specifications. Program integration, subsystem integration, system integration. Program integration interconnect modules. Subsystem integration interconnects programs. System integration interconnects subsystems. User acceptance testing. The newly developed software system is executed in near the user's operational environment and host computer configuration as possible. Therefore, it is also known as an operational demonstration. The purpose of this process is to ensure that the software system meets the previously defined system external specifications, acceptance criteria, and system requirements. Once the software system has been accepted by the user, formal certification of the system should be issued. The system is then ready for the file conversion, software installation, system integration, and final checkout in the full operational configuration. The programs are tested at an individual level, together as a system, and finally subjected to user acceptance testing. At the end of this phase, the system is ready and has been tested as a system by the developers. Using the test data, following test run are be carried out: program test, system test, program test. When the programs have been coded and compiled and brought to working conditions, they must be equally tested with the prepared test data. All verification and validation is checked, and any undesirable happening must be noted and debugged. Error correct. System test. At each stage of the execution, the results or output of the system is analyzed. During the result analysis, it may be found that the outputs are not matching the expected output of the system. In such case, the errors in the particular programs are identified and are fixed and further tested for the expected output. When it is ensured that the system is running error-free, the users are called with their own actual data so that the system could be shown running as per their requirements. The illustration of system testing. Implementation. In this video, we are going to see about implementation. After having the user acceptance of the new system developed, the implementation phase begins. Implementation is a stage of a project during which theory is turned into practice. The major steps involved in this phase are acquisition and installation of hardware and software, conversion, user training, documentation. The hardware and the relevant software required for running the system must be made fully operational before implementation. The conversion is also one of the most critical and expensive activities in the system development lifecycle. The data from the old system needs to be converted to operate in the new format of the new system. The database needs to be set up with security and recovery procedures fully defined. During this phase, all the programs of the system are loaded onto the user's computer. After loading the system, training of the user starts. How to execute the package, how to enter the data, how to process the data, processing details, how to take out the reports. After the users are trained about the computerized system, working has to shift from manual to computerized working. The process is called changeover. The following strategies are followed for changeover of the system: direct changeover, parallel run, pilot run, direct changeover. This is the complete replacement of the old system by the new system. It is a risky approach and requires comprehensive system testing and training. Parallel run. In parallel run, both the systems, that is computerized and manual, are executed simultaneously for a certain defined period. The same data is processed by both the systems. This strategy is less risky but more expensive because of the following facts. Manual results can be compared with the results of the computerized system. The operational work is doubled. Failure of the computerized system at the early stage does not affect the working of the organization because the manual system continues to work as it used to do. Pilot run. In this type of run, the new system is run with the data from one or more of the previous periods for the whole or part of the system. The results are compared with the old system results. It is less expensive and risky than parallel run approach. This strategy builds the confidence and the errors are traced easily without affecting the operations. The documentation of the system is also one of the most important activities in the system development lifecycle. This ensures the continuity of the system. Generally, following two types of documentations are prepared for any system: user or operator documentation, system documentation, user documentation. The user documentation is a complete description of the system from the user's point of view, detailing how to use or operate a system. It also includes the major error messages likely to be encountered by the user, System documentation. The system documentation contains details of the system design, program, their coding, system flow, data dictionary, process description, etc. The system documentation helps to understand the system and permit changes to be made in the existing system to satisfy new user needs. Maintenance. In this video, we are going to see about maintenance. Maintenance is necessary to eliminate errors in the system during its working life and to tune the system to any variations in its working environments. Maintenance must meet the scope of any future enhancement, future functionality, and other added functional features to cope up with latest future needs. It has been seen that there are always some errors found in the systems that must be noted and corrected. Maintenance also means the review of the system from time to time. The review of the system is done for the following: knowing the full capabilities of the system, knowing the required changes or the additional requirements, studying the performance. Principles of system documentation. In this video, we are going to see about principles of system documentation. Documentation is an integral part of various phases of the life cycle and is produced as a part of the phase. Documentation is a major means of communication. Documentation is a means of communication which helps over time after the analyst has left the project and the team has disbanded. The documentation is what remains. Documentation is the written form of record for the work. It establishes design and performance criteria for the project phases. Care needs to be taken to create good and effective documentation. Many system persons see documentation as a formality to be performed at the end of the stage rather than the work to be done as a part of the process. Poorly written and incomplete documentation is ineffective, which is not usable. Documentation should be created as a part of the process and not written after the fact. Documentation is the product of all phases. It should be a working byproduct throughout the life cycle. All the documentation should follow certain standards which are prescribed by the organization for the project. Documentation should be reviewed and approved for release. Obsolete documents should not be in circulation to avoid confusion. The procedure to be used to request for change in documentation, to evaluate and process such changes, to review changes made, and to release modified documents should be clearly laid. Unauthorized persons should not be allowed to change the documents. All changes made to the documents and the reasons why they were made should be noted as part of the documents. Standard used to create documents typically address the following: title page and documents ID, also with other identifiers like project name, version control information, names of author, reviewer, approver, date of release, version number, change control history, table of contents, figures and tables, scope of documents, expected reader profile, definitions and acronyms, other documents to refer to, specific references, overview or introduction, summary or conclusions as executive summary if relevant, main body of the documents, supporting appendices. The language should be tuned to the reader profile, clear, concise, comprehensive, courteous, precise, simple, flowing properly, easy to read and understand, maintaining continuity. Documents should include all necessary illustrations and tables. References should be provided for the ease of the user. The style should be consistent. The headings, style, and general appearance should be consistent. The hierarchy of the document should be clear to the reader. Technical editors are sometimes used to ensure that the documents are well written. The standards are derived using industry standard organizations based on quality model, previous experiences, and the opinions of senior staff in the organization. The illustration of system documentation. Types of documentation and their importance. In this video, we are going to see about types of documentation and their importance. Documentation is created at each phase of the project. The major types of documentation and their importance are tabulated in table given below. Document. Importance. Project request, information service request, information system request. Initiates the project and sets the first scope of the required system. Project directive. Typically created at the end of initial investigation, gives clear statement of problem, forms the basis of further work of the system. Feasibility report. Prepared as a part of the feasibility study, it gives the details of the study, the options are considered. It helps the management decide whether to go ahead with a system organization or not. System requirement specifications or requirement analysis or analysis report. Created during analysis, this provides the user as well as the designer with a what of the system forms the basis for obtaining user feedback and approval. System selection plan or technology requirements. Created during feasibility study phase and modified during analysis phase, specifies the hardware and software to be acquired for the system to be developed and to be run. Performance specifications. Created during analysis phase as a part of system requirement specification and sometimes a separate document, specifies the performance specifications of the system and forms an important input for design and testing activities. Design specifications. Documents the high-level and detailed level design, forms the basis for the actual development. For example, the module specifications are used to write the programs and the data designed to construct the database. System specifications. Sometimes created at the end of the design phase as a consolidated document containing a requirements, system selection, and design. Test specifications and plans. Specifies the testing approach and the actual test to be performed, forms the basis for performing the test both at development time and when the system is under maintenance. User manual. Created in the development phase to tell the operators how the system is to be used. A friendly and easy to use manual makes using the system easier and more practical for the user. Operations Manual. Created in the development phase to tell the operator how to operate the system. Operators may not know much about the system, and this need to be comprehensive enough to take care of both normal operations and error conditions. Project records. Records created while working on the project and using the system, like review reports, test logs, change requests, evaluation reports. Often, plan documents get ignored as they are used within the team. They are also important documents for a project to function properly. Plan. Description. Project plan or quality plan. Used to plan the use of resources, schedules, controls, etc. for executing a project with time, cost, and quality. Includes reviews and audits required. Needs to be regularly referred to and updated by the project manager as the situation changes. Also used by the management to review the project. Configuration Management Plan. Used to ensure the development's configuration management procedures are defined and used. Sets out what is needed to ensure version control and related configuration management issues. Test plan approach. Sets out the overall test plan strategy, which is then used to detail further into specific test specifications, plans, and test packs. Maintenance plan. The approach to maintenance activities and change control and the related resource requirements and reporting procedures are spelled out in this. It is used to handle the maintenance activities. Need for documenting the existing system. During the requirement analysis, facts are identified in the fact-finding study. These facts are analyzed to understand the processes, the data requirement and information produced by each process, and timing and volume of the processes. The system characteristics are important to understand the system, as they are used by the analyst to design a solution. The system characteristics are documented as requirement specifications. The following reasons establish the necessity of documentation. In information technology industry, the job attrition rate is very high. Lots of employees leave their jobs on getting better job opportunities. This adversely affects the ongoing projects. For example, a system analyst has been an important part of the system analysis team. Analyst has completed a large part of his investigations. If the analyst leaves the company at this moment, have to give his charge to another analyst. If the documentation does not exist, work done by former analyst will not be understandable by the later analyst. Oral communication is not an apt choice in cases where the matter to be communicated is technical. When a new analyst joins the company, he needs to familiarize himself with the ways of the company. The new analyst does this by studying the past and previous projects of the company. Enforcing documentation discipline in an organization. In this video, we are going to see about enforcing documentation discipline in an organization. The discipline of documentation has to be enforced in an organization. To ensure that the documentation is a part of the system team's work habit, it is necessary that documentation be considered an integral part of work. This implies that budget should include documentation effort. Procedures are set up to create review documents. Management does not say, as time is running short, just create the system. We will create the document later. To reinforce the integral aspects of documentation, completion of an activity should include completion of the associated document. For example, a phase should not be considered complete unless the documentation is complete. A program should not be considered complete unless it has required command lines. A unit test activity should not be considered complete unless the test packs and records are correctly available. The next phase should not be started unless a phase is complete, including the documentation. Documentation completion should be one of the aspects considered while evaluating work. To make documentation happen, the task of documenting should be made easy. To enable persons document as easy and proper, organizations should have in place standards which let the staff know how the document should be written. This ensures that good quality documents are created easily. Training in technical writing and workshop helps system persons write better. A technical editor may also be used to provide a more professional look. Tools should be available to simplify the task. Proper word processors and drawing tools with appropriately set up templates help in making the task easier and reducing the resistance. If documentation is not done clearly, then the person who is new to the team will not understand the concept of the project. The illustration of poor documentation.